Very good morning, my dear students. So in this class I'm going to solve some numerical problems on logarithmic decrement. Okay, so in theory class we studied about what you mean by logarithmic decrement, what is the importance of logarithmic decrement, and how we are going to derive this equation. Okay, logarithm expression for our derivation of logarithmic decrement. Okay, so in normally in mechanical system, so many vibrating systems are having what the logarithm decrement. Okay, so here many systems, okay, some amount of damping will be there. Okay, so here what we are going to study in this while solving the problem means here we are going to determine the damping factor. Okay, so logarithm decrement is nothing but what it is defined as a ratio of any two consecutive amplitude in an underdamped system is always a constant. Okay, that is called as a logarithm decrement. Okay, so here otherwise one more definition is here logarithm decrement, it is defined as what it is defined as the ratio of natural logarithm to the any two successive amplitude present in the mechanical system from its mean position. Okay, from its mean position is called as what the logarithmic decrement. Okay, so that is the ratio, that is x1 by x2, like that you have to take. Okay, so normally logarithm decrement is denoted by what delta. Okay, so delta is equal to, here there are three different types of formula we are going to derive here. Okay, so the delta is equal to what ln of x1 by x2, that is also a formula for this logarithm decrement, or that is divided by n. Okay, 1 by n is equal to delta, that is a ln of x1 by x2. Okay, so here the many mechanical students having that is a what the vibration part. Okay, that is a many system having what some amount of damping that we need to calculate here. Okay, so here we are going to solve the two numerical problems on this. So before solving problem I told you you have to remember the formulas. Okay, so here here I am going to use some here what I use the problems here, that is TV Gowda book. Okay, that is first edition, August that is 2013. Okay, so here question is given like this, so this is very important question. So find the logarithmic decrement ratio of any two consecutive amplitude of a vibrating system. Okay, find the number of cycle after which the original amplitude is reduced to 20% of the vibrating system and is defined by the following parameters. That is, they given mass is equal to the 3.5 kg. So normally mass is denoted by small m, not capital M. Okay, so here by mistake this is okay, small m is equal to 3.5 kg and stiffness is equal to 2.5 Newton per mm. So damping C, that is C is equal to 0.018 Newton second per mm. Okay, so this is the question they given. So here one mechanical system is given, that is a spring mass damper. So here mass is given, so mass is what 3.5. So stiffness is given, so 2.5 Newton per mm. Okay, and damping here the damping C is equal to 0.018. Okay, so I will repeat here, find the damping, that is the logarithmic decrement. Okay, so find the logarithmic decrement ratio of any two consecutive amplitude, that means what x1 by x2 you have to find out. Okay, so vibrating system, and find the number of cycle after which the original amplitude is reduced to 20%. Okay, so by using this quantity we have to find it. Okay, so first step is, so node on given data, so mass is equal to 3.5 kg. So here they given Newton per mm. Okay, we have to convert into Newton meter only. Okay, so that is the standard unit, that is standard SI unit. Okay, K is equal to 2.5 into divided by 1000, that is into 10 to the power of 3 Newton meter. So damping again here also we have to divide. Okay, C is equal to 0.018 into 10 to the power of 3 Newton second per meter. So by using this quantity, so given data we have to find out the logarithmic decrement of ratio. Okay, so before solving I told you number of times you have to remember the list of formulas. Okay, so we have the formula with us, that is omega n is equal to square root of k by m. Okay, so this is for the natural frequency, that is, so we know the spring stiffness, we know also what the mass. Okay, so just to substitute all the values here, that is a K is given here, K is equal to 2 point and mass is also given 3.5. Okay, substitute here, you are going to get the angular natural frequency is equal to what 26.72 radian per second. The unit is radian per second, that is R by S. Okay, so once if you know the omega n values, we know go for calculating this Cc. Okay, Cc stands for critical damping coefficient. Okay, so while deriving equation I told you, wherever Cc is there I will use this 2m omega n or 2m or 2 square root of k by m. Okay, both formula we can going to use here. Okay, so Cc is equal to 2m omega n. So here 2 right as in mass is given 3.5 and omega n is equal to, we already calculated right on here 26.72. Okay, so by using calculator you just to substitute, you are going to calculate, you are going to get what Cc is equal to 187.04 Newton second per meter. Okay, so we calculated omega n and we calculated the Cc, that is a critical damping coefficient. Now we have the definitions. What do you mean by this is zeta stands for what? Zeta is equal to what? The damping ratio. Okay, so it is defined as C by Cc. Okay, C stands for damping and Cc is nothing but what? Critical damping. Okay, so to find this damping vector we need for the some basic formulas to calculate all these values. Okay, So here you substitute all the values, that is c value also you substitute here. C is equal to what? 0.018 into 10 to the power of 3 they given in the question, that is the damping is equal to 0.018 into 10 to the power of 3 Newton second per meter. Okay, so now Cc we calculated here 187.08. okay, so you substitute here, we are going to get divide, we are going to get damping factor is equal to zeta is equal to 0.0962. okay, so this if the zeta value is lesser than 1, then we are going to call it as a underdamped system. okay, if the zeta value is greater than 1, then the such system are we are going to call it as what? Overdamped system. okay, if the zeta value is equal to 1, okay, then such systems are called as what? Critical damped system. okay, so before going to solving these quantities, that is the logarithm decrement ratio of any two successive amplitude, we need to calculate some basic like this. okay, with help of these formulas. okay, so we calculated what? Omega n we calculated, critical damping coefficient we calculated, and zeta also we calculated, and go for that is logarithm decrement. okay, first. okay, so we have the logarithm decrement, we have with us the three formulas. okay, so here we know the zeta value, so use this formula. okay, so logarithm decrement which is equal to, it is denoted by delta, which is equal to 2 pi zeta divided by square root of 1 minus zeta square. okay, so here wrote down here 2 pi into zeta value 0.0962 divided by whole square root of 1 minus 0.0962. okay, so if you substitute all these with the help of calculator, we are going to get delta is equal to what? 0.6105. so this is what the logarithmic decrement. okay, so have to remember this, delta is equal to 0.6105. okay, the ratio of any two successive amplitude is equal to what? Delta is equal to ln of x1 by x2. this is also formula is there. okay, I already told logarithm decrement can be calculated with the help of 2-3 formulas. okay, so delta is equal to ln of x1 by x2. okay, so here x1 by x2 we want the ratio of two successive amplitude. so x1 and x2 is nothing but what? The ratio, that is the amplitude. okay, maximum amplitude, minimum that is the maximum amplitude. okay, so here x1 by x2, if this log goes this side, means it will become power. okay, so e to the power of delta. so already we calculate delta is equal to what here? 0.6105. substitute here, x1 by x2 is equal to e to the power of delta. so if you substitute here, so you are going to get 1.84. so this is what the ratio of successive amplitude, that is 1.84 is the ratio of successive amplitude of the given system. okay, x1 by x2. okay, so they are asking what? Also number of cycle. okay, so number of cycle, what? Delta is equal to, we have this logarithm decrement formula, delta is equal to 1 by n ln of x1 by x2. so we already calculated this x1 by x2. okay, so delta is equal to 1 by n as it is ln of, okay, here look at here 20%. you read the question here. so the original amplitude is reduced to 20%, means 0. divided 20 by 100. so 2500 means you are going to get 0.2 reduce the original amplitude, that is x1. okay, so x1 is equal to, x2 is equal to 0.2 x1, that is a given. so substitute here. okay, so here delta is equal to 1 by n ln of x1 by x2. so wherever x2 is there, the original, this is reduced to 20% of original amplitude, means 20 divided by 100.2 into x1. okay, substitute here, you are going to get 0.2 x1. okay, so this x1 going to get cancelled, that is, otherwise here just to ln of x1 going to get cancelled. 1 by 0.2 is equal to 5. so delta is equal to 1 by n ln of that is the log of 5. okay, so delta already we know this, substitute delta also. so if you substitute delta here, so you are going to get the n number of cycle is equal to what? 2.63. okay, so this you need to calculate this, n is equal to 2.63. okay, like this you have to solve the problems on logarithmic decrement. okay, so I told to solve the coming, that is module 4 and module 5, we have to remember the list of formulas first. okay, so like this problem. okay, so next one more problem I taken here. so there is a problem number 2. so okay, so here look at, I will read the question now. so problem number 2, a vibratory system, that is a mechanical vibratory system in a vehicle is to be designed such that the following parameter. okay, so stiffness is given 100 Newton per meter, and c is equal to 2 Newton second per meter. okay, mass is equal to 1 kg. so with the help of this, a vibrating mechanical system is designed in a vehicle. okay, so to calculate the decrease in amplitude after the 3 complete oscillation. okay, and find the frequency of oscillation. okay, this means what? Calculate the decrease in amplitude after the completion of 3 oscillation. okay, so here look at in the complete oscillation, decrease oscillation means, so beginning is x0, x1, x2, x3. so up to x3 you need to calculate after 3 cycle. okay, so So here the given data note down again. So given data is equal to what? K is equal to 100 Newton per meter. Okay, damping is equal to 2 Newton second per meter. So mass is equal to 1 kg the given. Okay, so I already told to find the to calculate this you need some basic formulas. That is angular frequency is equal to what? Square root of k by m. So here k is also given 100 and mass is also given 1 kg. So it is 1 kg. So omega n is equal to what? 10 radian per second, omega n. Okay, so again we have the formula Cc, that is Cc is equal to what? Critical damping coefficient 2m omega n. So 2 into mass is given 1, omega n is equal to be calculated here, so substitute here 10. Okay, so finally we are going to get Cc, that is critical damping coefficient is equal to what? 20 Newton second per meter. Okay, so once you find this we can calculate easily what? Zeta is equal to C by Cc. Okay, so C is given 2 and this is C is equal to 20, substitute you are going to get 0.10. So here the system is also a underdamped system. Okay, zeta is got lesser than 1 value. Okay, so once if you calculate zeta value, go for calculating the this what? The logarithm decrement. Okay, logarithm decrement delta is equal to what? 2 pi zeta whole divided by square root of 1 minus zeta square. So we have the zeta value. So zeta value is equal to what? 0.10. Substitute here you are going to get delta is equal to 0.63. So this is the logarithmic decrement we already that is 0.63. Okay, so they are asking what? Ln of delta is equal to 1 by n ln of x naught by x3. So here read the question. So calculate the decrease in amplitude after 3 cycle. Okay, x naught by x3 at third cycle, what is the oscillation that is asking. Okay, so we have the formula. So normal formula, that is, and that in terms, this is the logarithm decrement in terms of oscillation. Okay, so look at here, this is the graph. Okay, with respect to displacement time. Okay, so initially vibration that it will came like this. It is a longitude. Here look at here, you are going to reduce the here going to reduction amplitude takes place by each cycle. Okay, so delta is the initial amplitude. Okay, so again x1, again x2 and x1. Okay, so maximum amplitude some little reduction. Okay, so this is the one cycle, this is a 2 cycle, this is a third cycle. Okay, so after third cycle you calculate the what is the oscillation. Okay, so based on this, so we have to calculate this. Okay, this is x stands for displacement, this is the time. Okay, with respect to time amplitude going on decreases and it will reaches to the this static equilibrium position, that is a horizontal line. Okay, so here delta is equal to 1 by n ln of x naught by x3. This is the original, this is after 3 cycle. So delta we have 0.63 which is equal to 1 by 3 ln of x naught by x3. Okay, so this ln of, that is logarithm of x naught by x3, keep it this side and this will become also 1.83. Okay, so we have this logarithm goes this side, it will become x naught by x3 which is equal to what? It will become power. Okay, so it is the power of 1.82. so x naught by x3 is equal to 6.62. Okay, so x naught by x3 is equal to, you are going to get 6.63. so x3 is equal to 0.15. Okay, so this is a third cycle amplitude. Okay, after third cycle we are going to get 0.15 original amplitude. Okay, so like this you have to calculate the problems on logarithm decrement. Okay, so while solving the problem logarithm decrement, I told you already, we are depending upon the given data, that is in terms of the given amplitude, that is number of cycle means use that formula, that is delta is equal to 1 by n ln of x naught by x3, like that. Okay, otherwise zeta given means delta is equal to 2 pi zeta by square root of 1 minus zeta square. Okay, so like this you have to solve the numerical problems on logarithmic decrement. Okay, so I told to before solving this logarithmic decrement problem you make the list of formulas. Okay, so I hope you understand this problem. Okay, so thank you very much.